This question has two parts. Part A is proving an identity. So we have to prove that this trigonometric fraction is equal to 4 minus 5 cos theta. Part B asks us to solve the identity equal to something else, like in the thumbnail. If you skip to 303, you'll be able to do that directly. In order to solve this identity, we need to understand that this isn't equals, but it's an equivalent. It's the three lines. That means that we can't just set them equal to each other, but rather we have to start with the left. So I'm just going to copy this down exactly the same. And what we have to do is we have to do maths in the middle, some kind of math, some kind of rearranging, and finally get to the right-hand side. So I'll do the 3 equals because there are 3 in the question. If it was a normal equals in the question, I'd just continue with the normal equals. So what identities do we know? From first year, we know sine over cos equals tan. That doesn't seem helpful, but sine squared equals 1 minus cos squared is also an identity that you should know, so I'm going to use that one here. I'm going to replace the sine squared in a bracket with 1 minus cos squared theta. Next step, I can just times this out. So I'll get 10 minus 10 cos squared theta, and then everything else is simply just the same. Next, I'm just going to add the 10 and the 2 to get 12. Everything else is the same, but I'm going to change the order because then that will help me factorize it. And this is still over the same denominator. Now, the idea here is that something's going to cancel in the numerator and denominator. So we kind of know that 3 plus 2 cos theta must be one of the brackets, and there's going to be a second bracket. If we work out the second bracket, we can have a 5 cos theta. It's going to be minus to give us 10 cos squared theta. And if we think about the first term, it's going to be 3 times 4 to give us 12. If we use the answer that's already in the question, we kind of know it has to be this, but it's always nice just to check by timesing out and making sure that we're still going to get all the same terms. This is still divided by the same denominator, but this is perfect because these denominators and numerator will just cancel right out. So this is equal to 4 minus 5 cos theta, which is the right-hand side. Therefore, left-hand side equals right-hand side. Identity is proven. In order to solve this equation, what you've got to notice first of all is that this left-hand side is exactly the same as in part A, except it's got x instead of theta. So the first step is always going to be use part A in order to rewrite the left-hand side. Part A was 4 minus 5 cos theta, but in this question we're going to change it for an x. The right-hand side is 4 plus 3 sine x. In this step, we can now take away 4 from both sides. So we're going to get minus 5 cos x equals 3 sine x. And now there's no squares in sight. So that identity is ruled out. What's the other identity that you know? Sine over cos equals tan. So I'm going to divide both sides by cos x, which gives us tan x on the right. If I divide by 3, then I'll get tan of x is equal to minus 5 over 3. I can't work out tan of x in my head. So what I'm going to use is the calculator. I'm going to do tan minus 1 of minus 5 over 3, and I'm going to see what I get. So using my trusty class whiz, I type in tan minus 1, we get this very, very long decimal. You'll notice that this answer is negative, hence it's not in the range. So we have to think about the tan graph, or use the CAS diagram if you really want, to find all of the solutions in the right range. So the tan graph looks like this, with asymptotes that I won't draw in. And that goes between 0 and 360 on the right-hand side. And minus 59 is somewhere on the graph on the left-hand side of the bottom, say about here. Other solutions which are in the same place are here and here. And what you need to know about tan is that you have to add 180 to get all the extra solutions. So I'll add 180 to that minus 59 to get about 120. And then add 180 again to get the next solution, which gives us about 301. And that's it. There are no more solutions in the range. So now I'm just going to give the answer to a rounded degree of accuracy. So the final answer would be x is equal to 120. I'll do it to 2 decimal places, 120.96 and 300.96. And here's another 2 to have a go at.